Well, hello and welcome to this presentation about further maths A level. My name's Mr. Lewis, and I'm just going to tell you and talk you through a little bit about what might be involved in taking further maths A level. Some Year 13 students have also made a short video about their experience of that, so I'd really encourage you to watch that maybe after this. Okay, so further maths is fourth A level. It is, I believe, the only subject you can do as a fourth A level at JCG. And you have to do regular maths A level in order to take further maths A level. You can't just do the further maths. So it's delivered 5 lessons a week, like every A level subject is, and it is timetabled within the option blocks. So you'll find it in one of the option blocks. Um, and you can take it with a wide range of other combinations of other two subjects in maths as well. What is further maths? It's it's math alongside and deeper than regular A level maths. So it provides breadth and depth. There are topics that you do in further maths which you wouldn't do in regular maths, and I'll talk a little bit about those in a minute. And there are some topics which you do study a little bit in regular maths, but you go much deeper into them in further maths. So it provides breadth and depth. Um, it provides stretch and challenge as well. So A level maths itself is a demanding course like many A level subjects, and further maths just gives you an additional challenge. However, alongside that, it's worth pointing out that doing further maths helps students develop a better sense of problem solving and tackling difficult questions, which helps with regular maths too. But we'll speak more about that shortly. Um, what's covered? There are three main areas covered in the further maths course. There's pure content. That's mainly algebra, trigonometry, and some of the things you've covered in your GCSE further maths course. Um, Along with that comes some new concepts, complex numbers, matrices. You've probably done a little bit of differentiation. You might have done a little bit of calculus. So if you haven't, you will do in year 11 as part of the further maths GCSE course. And that gets extended into differential equations and other forms of calculus. And then, so that's what's called the pure core, and that is 50% of the course. And the other 50% comes from two other topics. One is mechanics. Now you study mechanics in A level, so further mechanics takes that on just a little bit more. So you look at concepts like impulse and momentum, collisions, sort of pendulums and springs, and all sorts of different types of motion and forces. And then you look at some additional pure maths, which is number theory and group theory, and I'll speak a little bit about that again in one of the next slides. The specification is OCR. We do OCR for A-level maths and further maths. So two teachers in your 5 lessons a week at the moment. That's Mr. Abraham and myself for year 12 and 13. But next year there might be one or two other teachers teaching the further maths. So don't rely on it being both of us. It probably won't be. It's obviously terminally assessed like almost all A levels now. So there's no coursework. It's just 50% of it is the pure core, 2 papers, and 50% of it is the mechanics and the further additional core. So the pure core, just talk a little bit more about that now. So 2 topics that are quite fundamental to this are complex numbers and matrices, and you don't cover these at all in regular maths. So complex numbers works from the idea that let's pretend that you can do the square root of a negative number. I know that you can't square root a negative number, but let's pretend you could. And if you could, what would that mean? So we pretend you can, and we start with negative 1, the square root that, and we can't give it a number value. There isn't one, so we give it a letter I for imaginary. And studying how that develops into arithmetic with complex numbers or solving equations with complex numbers opens up a whole new area of maths. And interestingly, many of the applications of complex numbers create things which we use today an awful lot. I think resistors and some aspects of electronics are you couldn't do without knowing complex numbers. So it's quite interesting that a purely theoretical idea in pure maths has given rise to many applications of things around us. Matrices, you've probably met matrices in your further maths GCSE, arrays of numbers. Um, and they can be used for solving simultaneous equations, and you've met those with probably two variables, but you can solve simultaneous equations with many equations, many variables. And in fact, the way Google ranks pages when you do a search involves matrices. Um, so those are two ideas in the pure maths, and then in the mechanics, further mechanics, we might look at circular motion, for example. That's obviously how things move horizontally in circles. Anything from like driving around a roundabout in a car to something a pendulum to vertical motion in circles. So that might be something like a swing in a park, and can we predict how that will move and the forces and the speeds and the accelerations involved in that. So circular motion, but centers of mass, how things balance, momentum, collisions, what happens when two things crash into each other. Um, so those are all sort of studying the mechanics, further mechanics, and then the further additional pure goes really to the heart of what it means to have numbers. How they, what does divisibility mean? How can we divide one number by another? And for example, do the remainders tell us anything? That when you divide, one number by another, you often get a remainder. If it's zero, then it's obviously a perfect factor. But if it's not zero, then you're left with this thing called a remainder. And so we study a little bit of those, and that informs us about things like prime numbers. What do they mean? So that number theory is a fundamental part of university mathematics. So we have a little view into what that is like in our further maths course. What else? Group theory. Group theory is theory of structures in maths. So structures that might be applied to, for example, rotations and reflections of something like a triangle. You've got a picture here of lines of symmetry, but we can also have rotational symmetry. And we can think of all those symmetries as forming a group. And that structure of those symmetries also pops up in lots of other places. So we study some group theory, which is a big topic in university level maths. What are the grades like? Well, it obviously vary each year according, to all sorts of things, but typically A star to B is well above 80% every year. This year we've got 5 year 13 students taking further maths. It starts off with about 6, I think, and in year 12, and then we've got 16 students in year 12 taking further maths A level along with their regular maths A level, which is great. And so class sizes vary each year just depending on who wants to do it. You may find that as you do all this maths, that it's something you want to take further after school, and if so, you may well find you need to do some sort of admissions test for a university maths course, and we will provide you with support for that. We'll, give you. We have some extra lessons at lunchtimes after school, which help prepare students for the maths, which is what they use at Oxford, but other places too. STEP examination paper, and then there's a more recent paper called a TOMUA, Test of Mathematics for University Entrance. Those all happen in October of year 13, so we can give you some guidance and help you prepare for those. Lots and lots of career opportunities if you do further maths. It's an incredibly well regarded and respected A-level course because I think of, it's quite challenging, but it also shows that you're able to work with very abstract concepts and cope with those alongside your regular maths A-level and demands of that. So many more applications, increasingly more career opportunities than there were sort of a few years ago. So that's another good reason to think about taking it. Also, it's turning into a bit of a sales pitch, but I suppose that's the point. Another reason is that if you are applying for perhaps a numerate course at university, and I know that that's like two years away for you, but your offer can be reduced if you have further maths A level. So some universities will say, right, our standard offer fee, the course you want to do is, I don't know, 3 A's. But if you've got further maths A level, then we'll make it 2 A's and a B, something like that. Um, so that can be a benefit too. And some just examples of that here. These are from a year or two ago, but they're still, universities still reduce their offers a little bit, just one grade usually on one subject. Well, I mean, good question. Why bother? It's going to take up more of your school time, and it's going to take up more of your homework time. Why would you bother doing that? Well, an active brain needs stretching, doesn't it? Just like any other muscle, and further maths is a brilliant way of doing that. Lots of new ideas, lots of new concepts, and it will really sort of push you, which is great. Whether you've got 5 in your class, 16 in your class, everybody who's in the class has chosen, obviously, to do it. They want to be there, and that means that it's highly motivated. So lessons are really enjoyable. There's discussion and exploration of the concept with teachers. Teachers love teaching it as well because for teachers it's obviously the highest level of maths you do at school. So really interesting. And if you have Mr. Abraham, you might have some chocolate fingers at some point. Do you need to be the best in your class to do further maths? Definitely 100% not. If you think you really enjoy maths, and if you'll think you'll be reasonably okay with A-level maths, then definitely think about further maths. You don't have to be the best in your class. You've just got to be prepared to stick at it, give up the time, and yeah, you definitely don't need to be the best in your class. What if it's just too difficult? I think that's a reasonable question. I mean, what happens if you take it and then you find that it's just too much? Well, you can drop further maths A level without impacting or affecting at all your other A levels. So you haven't lost anything by giving it a go. That said, that's usually the end point. The bits in between are when we are persuading you to keep working at it, keep going. We'll offer you some, obviously lunchtime help or whatever. Lots and lots of help from JCD Math staff if you're finding bits a bit difficult. But usually what happens is you find one particular bit difficult and then you get through that and the next bit's fine. And the kind of seesaws a bit. But that's really all I've got to say about further maths A level. As I said, there's some year 13 students I just spit this video of them speaking about further maths, some of the challenges about time, because obviously you'll be thinking about, well, what about electives? What will I be able to do electives? Or, how's it going to impact my other subjects? And it's been very worth hearing what they say, because they're quite honest about it. They don't say, oh no, you'll be fine, there's plenty of time. They're honest and say, look, it will take some of your time, but there are rewards along with that. You may need to think about managing, how, having a Saturday and a Sunday job 6 hours a day. You might struggle if you're doing that and you're playing netball in the evening and all sorts of other things and doing 4 A levels. You may have to make a few choices. But that's no bad thing anyway. But so I would strongly recommend just see what they say about it. They've got to year 13. They love their further maths. So I think it's well worth watching that. I hope that's been useful. If you have any more questions, talk to your maths teacher about further maths. Ask them whether they think it'd be a good choice for you to make. Speak to myself or Mr. Abraham. If there's any aspects of the course that you think, I'd like to know more about that, or just send us an email. I hope, as I say, I hope it's been useful. But please talk to your maths teacher about if you have any further questions. Thank you.